Sample problem 18.6. Calculate the standard free energy changes for the following reactions at 25 degrees Celsius. The first one is CH4 gas plus 2O2 to form CO2 gas plus 2H2O liquid. So let's try that one first. This is a combustion reaction. Combustion reactions they release energy in the form of heat. So we should find that this reaction gives us it should be spontaneous. We should get a negative delta G for this reaction. The equation that we use is delta G of reaction is equal to the sum of the number of moles of a given product times the standard free energy of formation of a given product minus the sum of the number of moles of reactant times the standard free energy of formation of that given reactant. Products minus reactants. So we're going to look up these values. And so if you look them up for CH4, CH4 is negative 50.8. If you look it up for O2, it's 0. Okay. If you look it up for CO2, it's negative 394.4. And if you look it up for H2O, it's negative 237.2. That's in the liquid phase. It would be different for gas or solid. Okay? So we'll just do products minus reactants. So let's do the products first. So the first product is CO2, so 1 times negative 394.4. Second is water, 2 times minus 237.2. So products minus reactants. So minus 1 times negative 50.8 plus 2 times 0. Okay. So that looks pretty good there. So let's go ahead and add up the products first. So 394.4 and 237.2. So 1 times 394.4 negative plus 2 times 237.2 negative. And you get negative 868.8. minus 50.8, right? 2 times 0 is 0. So I'm going to add, that's the same as adding 50.8 to the original number. So plus 50.8, so you get negative 818. The units are kilojoules per mole. Okay? Now, our interpretation of that would be that in this calculation, this is a spontaneous process, meaning it releases energy as it occurs. You do not need to put energy in to make this reaction continue. It produces and it releases energy itself. Okay, so that's part A. Let's take a look at part B. Part B is 2 MgO solid, goes to 2 Mg solid. Now notice this is a lot easier than the previous sample problem where we had to look up we had to look up standard entropy values and then find delta S of the system. Look up delta H of formation numbers and then calculate minus delta H over T and then take those two and add them together, delta S of the system plus delta S of the surroundings. And then say, okay, if it's greater than 0, it's spontaneous. If it's less than 0, it's non-spontaneous. We just take these numbers, these free energy values, and if it's negative, it's spontaneous. If it's positive, it's non-spontaneous. So let's look these values up here. So for MgO, it's negative 569.6. For Mg, it's 0. And then for O2, it's also 0. That makes it easy, right? So delta G of reaction Products minus reactants, so 2 times 0 plus 1 times 0, right? Don't forget the coefficients, 2 and a 1, minus 2 times minus 569.6. This one's a little tricky only in the sense of the signs. This is 0 minus a minus or plus. Okay, so 569.6 times 2. And you get 1139.2. Okay. Well, that's 1139.2 plus kilojoules per mole. In other words, this is non-spontaneous at this temperature. At 298 Kelvin, 25 degrees C. Non-spontaneous, we get a positive value. In fact, it's very non-spontaneous, right? It's a very large number. You have to put in an enormous amount of energy to make this reaction go.